Sir, Dr. Sailesh Kumar, sir.
Yeah, I'm here.
Sir. Good morning, dear participants. I welcome Dr. Sailesh Kumar, sir, to deliver the lecture. Before starting the session, I invite our colleague Nikita Madam to introduce about Dr. Sailesh Kumar.
Uh, Good morning, one and all. I would like to introduce Dr. Shailesh Kumar. Dr. Shailesh Kumar is a highly accomplished AI and data science expert based in Hyderabad, India. Went over 20 years of experience in developing innovative AI and ML solutions across various domains, including banking, finance, retail, healthcare, and agriculture. He currently serves as the Chief Data Scientist at Geo, where he focuses on remaining sectors like education, healthcare through digital connectivity and AI. His areas of expertise encompass a wide range of fields, including artificial intelligence, machine learning, deep learning, natural language understanding, computer vision, and bioinformatics. Dr. Shailesh Kumar has been recognized with several prestigious awards such as the Team Superstar Award and the Faye Isaac Innovation Award, and was named one of the top 50 analytics leader in India in 2018. He has strong academic presence, serving as a visiting faculty member at institutions like ISB and IITs, and delivered talks at renowned forums such as TEDx and the World Economic Forum. His contributions to the field are also reflected in numerous publications and patents related to AI and data analytics. Dr. Shailesh Kumar is passionate about building a world-class team of AI researchers and data scientists to push the boundaries of what AI can achieve, aiming to leverage technology for transformative impact across various industries. A very warm welcome to you, sir.
Thank you. Thank you, Nikita. Thank you, sir, for inviting me. Good morning, everyone. Thank you for joining on a Saturday morning. So what I'll do is I'll kind of summarize my experience of AI in a 1 hour session. And I call it demystifying AI because there's a lot of mystery around it today, right? If you think about AI, different people have different opinions about what is AI. And I wanted to give 4 or 5 different perspectives on AI, and hopefully that will give enough ways of looking at the field, both at the philosophy level, application level, platform level, as a technology, and as a collection of algorithms, right? So we want to understand AI from different perspectives, so we get a holistic view of it, and that is what we want to be able to transfer to our students. Yeah. All right, so let's get started. So I'm going to start with a video of Star Trek. Star Trek is a very nice series that comes, and hopefully let me know if the audio doesn't work. So this is a series in which, it's 300 years into the future. Mankind is exploring space. And in this particular video, they are looking at an object in space and they are having a conversation about it, right? And once we watch it, then we'll come back. Let me know if the audio doesn't come.
Your sensors indicate?
Nothing, sir. Nothing.
Mr. Data, you must mean that it's empty of matter. There's always some energy formed to work.
Sir, our sensors are showing this to be the absence of everything. It is a void without matter or energy of any kind.
Yet this hole has a form. Data has height, width.
Perhaps. Perhaps not, sir.
It's hardly a scientific observation, Commander.
Captain, the most elementary and valuable statement in science, the beginning of wisdom, is, I do not know. I do not know what that is, sir.
So, hopefully we all are, scientists deep down, and we all understand the profound meaning of what we just saw, right? So if you look at how science has evolved, it started with I do not know, and then, we dig deeper, right? Why the apple is falling, why the moon is not falling, how come the birds are able to fly, and why certain things float and some things don't float in water. And all these questions led to profound discoveries in the world of science. And this is exactly the attitude we need to develop in data science also. So throughout my journey, I worked in different companies. I always start at the bottom and I say, I do not know what the domain is, and I do not know what the data is telling me. And with those two questions and armed with the tools of data science, we dig deeper, figure out what the domain is, figure out what the data is saying, combine the two to create solutions in those domains, right? And that is the skill, attitude that we need to develop in ourselves and in our students about the field of data science, right? So let's look at the 7 wonders of science, if you will. Today, mankind has made a lot of progress in science, but we still don't know many things. Although we know many things, but we still don't know many more things, right? So all these are things we know, but there's a lot more that we don't know about all these things, right? So for example, we know quite a bit about how the brain works, but still we don't know exactly and completely how the brain works, right? So the field of neuroscience is working on in that direction. We know quite a bit of how the mind works, but we still don't know how exactly the mind works, right? And there's a field, a lot of philosophies and psychology and many other fields are trying to figure out that. And these two are really the topics of interest for us. If you think about brain as sort of the hardware and mind as the software, then these two are the areas of interest for people like us in AI and all that. We still know a lot about how evolution works, genomics and all that, but there's a lot more we don't know, right? Only 2% of what our DNA does, we know, and 98% is still what we call dark matter of the DNA, which we don't know, right? So there's a lot of work to be done in that direction. In the quantum world, we know quite a bit now, thanks to the great quantum scientist of the world. But there's still a lot more that we don't know, right? The God particle is there or not. Sometimes we said it is there. Now we are not sure, right? So quantum world is a great mystery. We know a lot about how the planet works, but still we are not able to pinpoint or predict exactly when the next earthquake will come or the next, climate change event will come, right? So we know a lot, but we still can't know completely about that, right? Similarly, we know a lot about the universe, right? The black holes and all that, but still we don't know a lot, right? And these are beautiful mysteries and life, right? The biology of how it works. We know quite a bit. We have made a lot of progress in medical science and biological sciences, but there's still more that we are not sure of, right? So I think these are some of the great wonders of science. And I encourage my students to look at all of this with an open mind and say whatever is of interest to you, but don't get carried away that we have built ChatGPT and all this, so mankind knows everything now. There's a lot more to be discovered, and humanity will continue to make progress in all these areas. Right? So today we are focused on the brain and the mind, and that's the topic that people in AI and data science are wondering. So that is one perspective. The second perspective is what I call the convergence of technologies. Right. So if you look at today, there are many technologies that have come together. And this was not true, 30 years ago when we did not have cloud computing, we did not have IoT, we did not have devices. We had AI in some form, but we did not have mechanisms to deliver AI or to store the data that was needed to build great AI systems, right? But today we have. And that is actually changing a lot of things. And today, if you look at any application that we build, right, whether it is Zomato, Swiggy, Ola, Uber, or any of that, it's made because of this convergence of technology. So this is the second perspective that our students need to have, that knowing so many different types of technologies, how they work, is essential to build great products. And what is the role of every technology in each product that we use today is very important for us to understand. Yeah. And among these technologies, if I look at them, right, AI is still considered one of the most profound of these technologies because every other technology is just software, right? So 5G, 4G is just software. IoT is software, 3D printers are software, AR, VR is software. Everything else is software, but AI is not a software. It's a meta software, right? It's a software that writes itself in the form of a neural network, or it learns from data, right? It is not uh, programmed in the traditional sense, right? Now, this quotation caught my eye, several years ago. And if you really think about it, right, AI is now as horizontal a skill or a capability as fire and electricity, right? AI may not have reached the same level of, uh, you know, same level of acceptance everywhere, but still it is getting there, right? So today, in the last 20 years, we learned how to build great search engines, great ad and marketing and some of that. But AI has still not reached the masses, right? Our farmers are still struggling with the right advisories. Our teachers are struggling with what to teach next, what is the best content. Our patients are struggling with, what is the diagnosis of my disease? Can AI help? So the idea is that AI has solved some great commercial problems in the past. And the next 2 decades, we are going to see a complete social application and social transformation that will come from AI, right? Think about the transformation that electricity brought. Think about the transformation that internet brought. Now think about the transformation that AI will bring, right? And that is the beautiful reason why our students should be very excited about this field, that we'll be able to transform lives of millions of people directly with AI, right? And that is the promise. This statement is about the promise of AI, not the achievements of AI so far. And there's a lot of work to be done to get there. Now, if I pause and give a different perspective, right? What makes a great product today? So this is the product perspective on AI. So if I look at the great products that we use today, right? So we use, maybe I can, throw it out as a question so we can make this a little more interactive. So if you can unmute and tell me what are your favorite products, why do you like them? Is that facility available to unmute? Yeah, please unmute and feel free to chime. What are your favorite products that you use every day, especially in the digital world?
Sir, good morning, sir.
Good.
Myself, Dr. Sagar from VNRVJIET.
Mhm.
So regarding the question that you have raised, the different AI tools and techniques that I'm impressed is the Google Assistant and Apple Siri.
Mhm.
And this makes the personalization of our digital world and makes our life very happier.
Correct. Very nice.
Thank you, sir.
Thank you. Very nice. Anybody else?
I think so. One of the most important product that I feel is that that Google Pay and all that wallets and all, because in a workplace also you're sitting, you can simultaneously send some money and all this thing. So it is cutting down our work, increase in our productivity and all. I think that's one of the great product I feel so. Sir.
Correct. Very nice. Yes. Very nice.
Good morning, sir. Myself, Dr. Pramod Kumar from SR University.
Yes.
Yeah, one of the greatest product I feel is Google Maps, sir.
Google
Even the person who doesn't know technology also can reach the destination through the use of that app, sir.
Yes. You really hit it on the nail. I feel Google Maps is one of the most useful, most used, most advanced product. And we all use it every day. We don't use Google search that much every day, but we use Google Maps every day, right? At least, if you are looking at whether it's Ola, Uber rides or whether directly, right? So yes, very right. Okay.
So recently,
morning,
Canva has, so this is Anuradha, and
Hi, Anuradha.
Canva has really taken over. So it really made abundant so many other applications and also even designers actually made everything very easy.
Correct. Canvas. Yes, very true. Yes, yes.
Sir, I'm Dr. Srinivas. I think ChatGPT is today's wonderful product.
Yes, yes, yes.
For example, to learn any new concept, you can learn very quickly using that.
Very nice. Yes, exactly. ChatGPT. Yeah. So both for creating designs and for understanding and learning topics, we are able to use these kind of Gen AI tools. Yes, very nice. Any others? So how about, Ola, Uber? Will that be a product also, right? Swiggy, Zomato, right? Social media, Facebook, LinkedIn, Instagram, right? So these are all products, and we talked about some of them. So thank you for that. Right now, the question is, what is it that is common among all these products? Right? What makes these great products great, right? And let's talk about the 5 I's that make a great product. And this you will see common among all the products that we talked about, right? So the first I is what I call infrastructure, which means these products were built for the planet, not for the PC, right? So if you look at your Gmail, your YouTube, your Google Maps, your Siri, Alexa, your ChatGPT, they're not sitting on your PC. They're sitting on the cloud. Billions of people can use them simultaneously, and they can scale without a problem, right? So this is the first important characteristic of a product, that it is a scalable, right? Now, let's divide products into 3 categories. One is what I call purely physical products, like cars and washing machines and air conditioners and fridge. So these are physical products, and they scale because of our ability to manufacture them at scale, right? So manufacture, distribute, sell at scale, and we are now able to scale up our physical manufacturing of physical products. Then there are purely digital products like YouTube, Google Maps, Instagram, Facebook. They are purely digital products. There is nothing physical about them, and they can scale infinitely because of the cloud. So the infrastructure of the digital products is almost infinite, right? Google does 5 billion queries a day. Netflix runs so many movies simultaneously, millions of them at the same time, and they can just scale like crazy. And I think if this doesn't surprise us, wows us, then we are just taking it for granted that scale is now possible, right? It's an immense amount of scale, and our students should appreciate that this is the amount of, our manufacturing capacity has increased so much, our farming capacity has increased so much, our digital capacity has increased so much in the last 20 years, right? Now, the third category of products is what I call digital physical products. They are hybrid products. Some things happen digitally, some things happen physically. Can anybody give an example of a digital physical product?
IoT based projects, sir. Products, sir.
Because the sensor is physical, the data is digital. Yes, very good.
Sir, smart home.
Smart homes, very good. Yes, so the home is physical and the data and control can be digital. Yes. Something we use every day.
Mobile, sir.
Mobile, yes, you can say it's a combination of hardware and software. So there is a physical mobile and there's a software. But I'm talking about, products. Smart TV, yes. See, anything that is hardware plus software is a digital physical product, right? That is not what I'm looking for. I'm looking for when you use a product, you use it in both ways. As in, so for example, right, Ola Uber is a digital physical product. That means you do certain things digitally on Ola Uber and certain things physically happen, right? The ride is a physical experience, but booking a ride, making a payment is a digital experience, right? Similarly, e-commerce, right? Amazon, Flipkart, these are what we call digital physical products, where you do most of the things digitally and delivery of the product is physical, right? Now, when we have digital physical products, how do they scale? which part of there is the digital part or the physical part is the limiting factor?
Physical part is
Physical, right? Because you cannot have infinite cabs, infinite cloud kitchens, infinite warehouses in the city. So that physical part is the limiting factor, and that is where operations, resource management, optimization becomes more and more important for these kind of products, right? So very nice, right? So this is the first I. The second I that we all talked about is the interface, right? How do we interact with each other is through language, through speech, through gestures. Now, slowly, AI, you talked about Siri, Alexa, and all of that. And ChatGPT is already, I think, speech enabled. So now imagine interfaces are evolving and they are becoming more and more natural and more importantly, inclusive interfaces. Inclusive means everybody, not only the person who knows English, but all Indian languages, we are all able to use them. People who don't know how to read, but who can talk and listen, can also use these products because of speech. So this is another area that is of great interest to the country, which is how do we make speech-enabled products for all use cases for all Indians across all languages, right? This is a big initiative by the government, Bharat GPT, all of that, Vahini project, and I'm sure some of you are participating in that. And for India, speech is not about a cool factor. Speech is about inclusion, that every Indian is able to get onto the digital bandwagon, and every Indian should be able to say, hey, I have fever in their own language, and an AI should be able to help them diagnose the fever. Every Indian should be able to say, I want to learn Pythagoras theorem in their own language, and an AI system can teach them through ChatGPT in their own language at their own level. And that is the potential of where we are trying to go. Yeah. So interfaces are becoming more and more natural. The third I, can anybody guess the third I? If only these two things were great, if they can scale and easy to use, will that still make a good product? What is the third I that we need? The reason why we are all here. Hello.
Is it performance, sir?
It starts with an I.
Intelligent.
Yes. Right. So the third I is intelligence, right? And it is, this ability that, why does Google auto suggestion make sense to us, right? Why does Amazon recommendations make sense or YouTube recommendations are very relevant, right? Why does Ola Uber send a cab from within 5 minutes, not from 2 hours away, right? Why, the pricing of airline and products is in a particular way. All this is intelligence, right? So the idea is these three I's make a complete product today. A product must scale, it must be easy to use, and it must show intelligent behavior. Only then this is the MVP of a new product. This is the minimum viable product. It must have all these three qualities, right? The fourth I is what I call instantaneous, right? So today we want a Blinkit to deliver in 7 minutes, right? Ola Uber to come in 5 minutes, right? Pizza delivery in 30 minutes. Netflix should start downloading immediately. Google search is happening in, half a second, right? So we are now used to of instantaneous. Even banking approvals of loan should happen in 5 minutes, right? That is how they are advertising. So now we are also looking at real-time decision making, intelligent decision making, all this happening. And the fifth I, which has not yet happened completely, is going to be something we'll cover later, is integrated products, right? Integrated as in, if you look at the airline industry, it's a very integrated industry, right? You book tickets somewhere, you go to airport, security, aircraft, maintenance, everything is happening, pilots, food, right? Airports, everything is happening, baggage delivery. It feels like an integrated product. But if you look at the agriculture system of our country, right, it doesn't feel aggregated. integrated, right? Because satellite data is there, soil IoT data is there, Mandi is there, equipments are there, fertilizers and chemicals are there, their supply chain, seed and produce, the cold storage, everything is there. But they don't feel integrated. Right? And similarly, if you think about the healthcare ecosystem, the education ecosystem, we have building blocks, but we need to be able to integrate them. So one example of this could be, if you think of GPS as a great technology, Tesla autonomous car as great technology, Google Map as great technology, the maintenance of cars as great technology, the traffic signals as great technology. Now, if I integrate all of this and create a connected car ecosystem which optimizes every ride jointly with everybody else, and also does maintenance and insurance, all of this together, that would be an integrated product. So we understand that integration is where the next 20 years is going to be, and we are going to build smart cities and more such integrated products in the future. And that is what we have to prepare our next generation for, right? How to think bigger, more complex systems, and all of that. Okay. So now, to get there, what are the core skills that we need to teach them, right? And this is what I tell my students in Geo Institute and ISB, right? So the first is, we need to respect the domain knowledge, right? If you want to build products in a domain, healthcare domain, agriculture domain, uh, any domain, right? Physics domain, science domain, we need to understand and appreciate the domain. And every time I moved from finance domain, was my first job, I had to learn about the finance domain, how to build credit models, fraud models. Then I went to search engine companies. I had to learn how to think about search properly, right? Then I went to Ola, Uber. I had to understand the domain all over again, right? So domain understanding is very important. The second skill is, obviously we live in a big data world. So big data thinking, MapReduce, Hadoop, all of that is very important. Uh, then all the AI ML algorithms that we are telling, all the way from simple statistical models to deep learning models, Gen AI models, the whole spectrum, all that is very important. And a lot of math and stats as a foundation to all of this is also very important, right? So all our courses are designed in such a way. But what is the final skill that comes together when our students learn all these four skills? What is that ultimate skill that we are learning is the sum of the parts. And I call that the skill of formulation. The art of formulation is what is missing, because we are learning how to use a hammer, how to use a chisel, how to use a nail, but we are not learning how to build a chair. And that is the skill that we need to teach. How do you combine all these four skills to solve a business problem? That is the art of formulation. So let me dwell a little bit on this, right? And, all great scientists, including data scientists, would really develop this skill of formulation, because like Einstein said, mere formulation of a problem is more essential than its solution, right? Solution can be done. See, there are software programs, you have Jupyter notebooks, you have cloud computers to solve the problem. But who is going to formulate it is the new skill that we need to develop, right? So let's look at some examples of this. Uh, so you remember these word problems, right? In algebra, word problems. And here is a business use case, a real world situation given to us. And, a lot of us struggled with this class of problems, right? We knew how to do a linear equation, but to create a linear equation was the problem, right? Now, if somebody could figure out what is given, what is asked, what is the relationship between given and asked, and write down the equations, then solving the equation is easy. But coming up with the equation is hard. So now we have to teach our students how to do this, not this. This was done in 10th grade or 4th grade, 7th grade. But what is the equivalent of this in data science, right? And that is what the skill that our students need to learn, right? So for example, the real world when they go out, they're not going to be asked to build a clustering algorithm for something. They're not going to be asked to build a classifier or a regression model. That's what we are teaching them. But that's not what they are asked to do. What they are asked to do is, does this X-ray show a TB or a COVID? Right? What is the next topic the student is ready to learn in an edtech system? What crop should a farmer grow next? How many iPhones should I stock in Mumbai next week? Where should Swiggy open its next cloud kitchen? Which movie should I recommend? Right? So on and so forth. So the idea is the skill that we need in our students is, on one side, they should know all the tools, and on one side, they should know all the pain points, and then they should be able to do a matching problem and say, oh, what is the best query for result for this query is an information retrieval problem. And how many cabs should I need on next Monday is a demand forecasting problem. And which customer is about to churn is a classification problem. And this is the skill that they should be able to solve a business problem, create an AI architecture for that, and then solve the problem for the business, right? And hopefully our education system in data science will evolve, that we'll present them with a lot of real world problems to solve, and then work backward and say, now tell me what data you need, what features you want to create, which type of modeling technique you want to use, and how will you evaluate the goodness of your solution, right? So those high-level skills will make them much better data scientists. All other skills on how to build a classifier or a recommendation engine, they can learn from, online videos and chat. So now let's talk about the second part, which is a fundamental question I start with, right? What is intelligence? So we want to build intelligent system, but let's open up the floor. Again, please tell me, what is your opinion? What is intelligence? Any thoughts?
It's the capacity to take the decisions.
Okay, very good.
It is like you have a lot of knowledge in your brain and the capacity to use that knowledge.
Yes, capacity to use the knowledge, right? See, ChatGPT has so much knowledge of the world, if you think of it as an intelligent brain-like system, but how to respond to one prompt versus the other, it does a good job. Yes. Okay, what else?
Intelligence means, sir, it is like how have the ability to how quickly we can, acquire and apply the knowledge in the right way, sir.
Yes, yes. Apply the knowledge in the right way, right? Very good. Yes. Okay. Acquire and apply. Very good. Both are important. Yes.
To continue to that, it's continuous learning. Acquire
Continuous
and
learning.
apply. Yeah. Acquire and apply the knowledge through continuous learning.
Correct. Very good. What else? Continuous learning. Very nice. And if you look at that, what Sir just said, I think we do continuous learning, right? Throughout our lifetime, we learn how to do the same thing better and better, right? So yes, and Google search has been improving continuously for the last 20 years. It's not deployed once. AI is not something like IT. It is deployed. It actually improves over time. So continuous learning is the key. Yes. Any other thoughts? So how about the ability to play the game of chess or solve a math problem? What kind of intelligence is that? That is the ability to do what?
Execute a task.
Execute a task, but what do we call it, right? When you say, oh, it's now your knowledge representation, yes, but task and knowledge representation, combine these two ideas now, right? What are we doing?
Decision.
Make a decision.
Taking a decision.
So is it skill?
Skill, what skill is it? What is it called? When I say, oh, solve the problem, what do you say? Wait, I am?
Problem solving skill?
I am thinking, right? Thinking is a skill, right? Thinking
okay.
and reasoning, right? Very good, right? So in my mind, there are 5 levels of intelligence, 5 kind of skills that we develop, right? So we talked about learning and continuous learning. So the ability to learn, right? Ants can learn, dogs can learn, humans can learn, and now AI systems can learn, right? We learn how to talk, walk, play music, gymnastic, everything, right? By training our muscles in a certain way, our hands, whatever it is, we learn, right? The second skill is understanding, right? When I'm saying something, you are able to understand what I'm saying. We are able to understand what is a COVID virus sequence looks like, right? What it is doing. We are able to understand a video camera, images and videos. We are able to understand movies, understand speech, understand text. What is understanding? The third is what we talked about, thinking. Thinking is when we are solving a multi-step problem, right? Solving a math problem, crossing a road in India, right? Having a conversation. These are all thinking problems. Playing a game of chess, right? So we'll talk about what is thinking. And the fourth one nobody talked about. What skill have we learned in ChatGPT and all that? What is that part of intelligence?
Training?
Not training. Training is a mechanism to get there.
Mechanism, okay.
Think of these 3 words. What is the 4th word that is missing?
Sir, analysis?
No, analysis is understanding, right? You are given a data, you are analyzing it. What is the opposite of analysis?
Applying.
Applying.
Evaluation.
Evaluation.
Applying knowledge. Evaluation. Applying knowledge.
No. So what is this ChatGPT thing called? What is all this called? Which type of AI it is called?
Generative. Generative AI.
Generative AI. Generation. Generation is the 4th skill. We call it creativity, right? And if you think about who are considered the most intelligent people are the most creative people. It doesn't matter whether you are a comedian who is creating jokes or an Einstein who is creating theories or a musician or an artist or a journalist, right? Everybody who is creating something from nothing, just an inspiration and create something is the 4th skill. So these are the 4 skills of AI. And the reason that modern day is very interesting is because we have reached the 4th stage of AI, creativity. Gen AI has crossed the 4th stage of AI. And there's debate going on about whether it's the right way or the wrong way, but it is a way. And we are all excited and fascinated by it. And why is this 4th stage very important? So if you think about it, when we ask our children to read a book and understand, that is understanding. Now, if only you can read and understand text and literature, is that a complete training in literature? No, right? You also should be able to create and generate text. You should be able to write a letter, write an essay, write a debate, generate something. Right? Same thing with images. If you are able to only consume images, understand images, but not generate images, right? Through art, painting, CAD design, what have you, then you're not creative, you have not completed. So analysis and synthesis together completes an AI system. Analysis and synthesis, listening to music and creating music, listening to text, creating text, right? Both are important. And that is why 4th stage of AI, the creativity was very important because until now we were only understanding text. We were not creating text, right? So that is what makes this stage important. Now there is a 5th stage that everybody is warning us about. So if you look at what Jeff Hintons of the world, Elon Musk of the world are talking about, they're warning us about the 5th stage of intelligence. Can anybody guess what is the 5th stage of intelligence? And we all go through these stages. Beyond all this, what happens? When we combine all this, what happens when we cross a certain age, for example? When we are a teenager, what happens? Huh?
Ethics.
Ethics, very good, right? So there is a notion of ethics. There is a notion of ethics is part of that. We become self-aware, right? And then we start asking questions like, why should I listen to my parents or my teacher? Why should I do this? Who am I? What is my purpose? Now imagine if AI, which has almost reached a teenage, if you will, and it starts questioning us, right? And saying, why? Why are you ordering pizza on a Swiggy app when your Fitbit is telling me that your heart rate is not correct, right? The why question, right? And now AI can become next level intelligent. And now the repercussions are, going to be driven by the ethical side of it, right? And this is exactly like raising a child. If you think of humanity as the parent, AI as a child, what will the child do when it becomes self-aware? It depends on how the parents have raised the child, right? This is pretty much what is going on at a planet scale now, right? So we can be redeemed by AI and we can be destroyed by AI. It is up to us. This aspect of AI, we should teach our students that with great responsibility, the power comes great responsibility, right? So why ethical AI is important? Okay. So now let's go deep into each of these so we can really understand the difference between these four facets of AI, right? All right. So what do you see?
A written in so many ways.
A written in so many ways, right? Now, if I ask you, have you seen these A's before? Not in this form, right? You've seen A's in your life, but you've not seen these A's, maybe one or two, right? Now the question is this. If we were a memorization system, if human brain was a memorization system, we should have remembered all the A's we have ever seen, compared them exactly to each of the A's here, and do like an SQL query and say, oh, this looks like an A, because I remember an A I have seen before. Is that what we do? Are we a memorization system? Do we remember every A we have ever seen? Or every car, every object, every crow, every bird, every fish? Do we remember everything? Are we a memorization system?
No, to some extent, sir. To some extent, but yeah, not.
But what
exactly.
happens? Yeah, we cannot, right? Possibly we cannot. And so what does our brain do? Is when we consume data, right? Somebody said this is A, this is car, this is grandmother, this is dog. What do we do with that data? We build a model and we keep improving that model. So we are not a memorization system. We are a generalization system. We are able to generalize the data that we see. This is a very important skill. This is exactly what we test in our education system. We don't want our children to memorize the 5 quadratic equations they have been taught in the class. We want them to generalize to any quadratic equation that will come in an IIT exam, right? So from memorization to generalization is the art of learning, right? We learn to generalize. Now, why is that important? Why did nature decide that memorization is not important, generalization is important? Generalization means similarity engine, right? Have I seen something similar before? So our brain is a great similarity engine, right? Now, why is generalization more important? Think from a evolutionary perspective, right? In our lifetime, we have never experienced exactly the same thing again, right? The same commute is different slightly every day. The family members are different. The office and the students and the classrooms are different. We will never experience exactly the same thing ever again. Same thing happens with tigers and deers in the predator-prey scenario. They will never experience the same thing again. Therefore, nature decided, I don't need a retrieval system. I need a generalization system, right? This is similar to what I have seen before. And that is the foundation of machine learning, which is generalization, right? So that is what we are learning. We learn to generalize, right? Okay. So what is understanding? Can anybody think about what is understanding?
Interpretation.
Correct, right? Interpretation of something. So when I see a bunch of pixels on a TV screen, what is falling on my retina is a bunch of pixels on my retina. But what I'm actually seeing, looking versus seeing, what is the difference? What I'm actually seeing is not a bunch of pixels. I'm seeing a rose flower, a car, a chase scene in a Mission Impossible movie or whatever. So understanding low-level data, pixels, to high-level semantics is understanding, right? So let's look at some examples of that. So when I show you these two red lines, what is the meaning of these red lines? There's no meaning, right? They're just two parallel red lines. But now, if I ask you what is the meaning of these two red lines, what has changed? What happened?
One is a fork, another one is
correct, a needle, right? Now,
yeah.
why the understanding of the same line has changed? What has changed the line's understanding? What have I added between this and this?
Context.
Context, right? So this is the power of understanding that the content is the same, but the context is different. And therefore, the meaning of the content is derived from the context. This is the fundamental principle of understanding. Same thing in the sentences below, right? I was right to avoid a suit against Apple. Man in suit on my right was drinking apple juice. You see, the content is same. The three words are shared between the two, but our brain is processing them differently and saying, no, they are not similar at all, these two sentences, right? They're very different because the context is different. Therefore, the content has a different meaning. And this is the power of how our computer vision systems work, how our language understanding systems work, speech understanding systems work, video understanding systems work. They all work on this basic principle. That's why convolutional neural networks, right? They bring context into the content, right? And this is the fundamental principle of understanding. Now, this principle was codified by Dr. Rupert Firth, and he said, you shall know a word by the company it keeps. Now I can extend that principle. You shall know a pixel by the company it keeps, right? For example, a red pixel on a TV screen could mean so many things. It could be part of a red flower or a red dress or a blood stain or a red car. It's the context that gives meaning to the content, right? How does the sound? A particular sound could mean different things in different contexts. A symptom, if you go to a doctor and say, I have fever, that alone is not enough. He cannot diagnose because there are 500 diseases where fever is a symptom, right? It could be all the way from a brain tumor to a simple viral fever. You cannot say. So what are the other symptoms? When did this happen? How long ago? All that has to be asked. A fever with rash, fever with vomiting, fever with headache are different things. So it's a context that gives meaning to the content, right? Same thing, a gene is triggered by another gene. By itself, a gene has no meaning, right? So this is the principle. This is the foundation of all your BERT models, all your language understanding models and vision and speech models, right? Okay. So the next kind of paradigm in AI is thinking. So what is thinking? Let's look at that a little bit, right? So if you look at Google Maps, and we talked about why Google Map is important, what is it doing? It is really solving a multi-state decision problem, right? So you give it a start state and an end state, and you say, I want to go from here to there. And then what is Google doing? And you are in a current state. And what is it really doing deep down? It's not just running a Dijkstra's algorithm, right? It is doing something more fundamental. And in a way, right, we can make it think like that. So there is a notion of state. What is my current state? There is a notion of feasible actions. What are my possible actions in the current state? And which is my optimal action among the feasible actions. And as a result of that, what is my next state? So this paradigm of thinking between state and action is a thinking paradigm, right? Same thing applied to games of tic-tac-toe, chess, AlphaGo. What is my current state? What are my possible actions? Which is the best action, right? Same thing I can apply to math. This is my current state. What are my possible actions and which is the best action, right? This three-stage process done recursively is thinking, right? And now who tells me the, who tells me my, so there are three skills here, right? One skill is how do you define the state of something? Second skill is uh, how do you come up with the set of feasible actions in that state? And third skill is how do you learn over a period of time what is the optimal action among the feasible action, right? So these are the three skills. One is knowledge representation, somebody talked about. How do you represent the state? And then how do you do feasible and all? So tell me, who is telling me the feasible? What is the feasible action in math or feasible next moves in a game or feasible, turns I can take on a Google map? Who is telling me that? Where is that coming from?
Of all possible solutions, the best possible solution is feasible solution.
No. Feasible means all feasible. Feasible means possible.
Possible.
Optimal is a subset of feasible, right? Which among the feasible. So I cannot make any turn on the road, right? I cannot go inside the river or make a turn when there is a red light, right? Similarly, in the math world, I cannot just do any transformation on the current expression. So in the world of Google Maps, the map is the domain knowledge, right? In the world of games, the rules of the game are the domain knowledge. In the world of math, the axioms of mathematics are the domain knowledge. So they define what is feasible in the current state. And that alone is not enough. So earlier people talked about knowledge and using knowledge to do things, right? So knowledge is the domain knowledge tells me what is feasible. And what is optimal comes from the ability to reason over that knowledge, right? And say, if I do this, then he will do that, then I will do this, then he will do that. So I'm reasoning, and then I'm deciding this is a good move or that is a good move, right? Same thing in math. If I go this way, then I will have to go this way, and will I find a solution or not, right? So how is this relevant to AI, right? This is an AI paradigm. Now think about if I want to build an advisory system for an agriculture for a farmer, right? Again, I can think about what is the state of the crop, state of the soil, right? So those are my state representation, knowledge representation. I have satellite data, I have, I have soil IoT data, I have weather data. Together, I can define the state of the system every day. And then, right? And what are the actions in agriculture? So I can now give advisory, right? How much water, what fertilizer, if at all, how much fertilizer, what pesticide, right? And all that. So state and action thinking is very useful. Similarly, if I have to build an edtech system, right? The student has a learning state. What does he know? What does he not know today? Think of 7th, 8th graders, and now in a particular subject. So given the state of learning, I can now take an action that, oh, you know Pythagoras theorem, you are ready to learn sine theta, cos theta. But if you don't know Pythagoras theorem, I will first teach you that, then take you to the next step. So this ability to go back and forth between state and action is a very profound skill, and reasoning and planning and all of that part of AI. This is going to be the next big wave after Gen AI, thinking and reasoning systems, right? So we need to be able to teach our students all these four skills: learning skills, machine learning and all that, understanding skills, right? Computer vision, speech and all that, thinking skill, which is reasoning and all that. Like, here's my current state. These are my options. Take one option. Again, what are my options? Again, what are my options? And I keep solving them. Yeah. Okay. So we understand the three skills. Now we'll talk about creativity. And creativity is a very interesting thing. We are all fascinated by it now. Here is an example. So we asked GPT-3, this is GPT-3, I think, to create a story. So the first sentence and the last sentence are given. I was going walking in an empty parking lot versus last sentence, I safely returned home. And it's supposed to make a story out of it. And this is what it created, right? I saw a suspicious man who was walking towards me. I turned around and ran the other way. The man started running after me. I ran as fast as I could. The man couldn't catch me. I safely returned. This is something ChatGPT has created. This is something that a 5-year-old would also have created, right? So we understand creativity. Now, here is a big debate going on in the Gen AI world, right? Jan LeCun recently said that although Gen AI is fascinating, the results are fascinating, it doesn't understand what it is doing, right? So what I mean by that is, does an LLM model actually understand what is suspicious, what does catch me, what does safely, what is the parking lot? How do humans understand what is a parking lot? Tell me. Do we understand what's a parking lot by reading about parking lots in a piece of text? How do we understand a parking lot or suspicious?
We experience it, sir.
Exactly. We experience it, right? So human understanding of the world is multidimensional, multimodal, experiential in nature. How does LLM think about an embedding of a parking lot phrase? Is by looking at, token number so and so occurred before, token number so and so occurred after. Therefore, this token, parking lot, whatever, right? Mall, movie theater, these are all similar in some way because it has never experienced it, but it has seen words before and after. This is exactly not how humans learn, right? We don't learn to create by looking at the last 1,000 words that I have written, and now what is the 1,000 plus first word that I should write? This is exactly not how humans generate text, right? Right? Imagine if that's how Harry Potter was written. This is not how Harry Potter was written, right? So the idea is, yes, creativity, the way we see it today, is fascinating, but the way it is done is exactly not how humans do it, right? Same thing with machine translation. Machine translation is great, but this is not how humans learn to translate by looking at patterns of words in one language and the corresponding sentence in the other language, right? Similarly, humans don't learn to see the way machines learn to see, right? We don't learn to see when our mothers say, open your eyes, here is a letter A, here is a cow, here is a cat, now close your eyes. Now I'm going to show you the next random image. I'll tell you the label, again close your eyes. Is this how we learn to see? We don't learn to see in a supervised, labeled example way, right? So you see that AI is creating fantastic results in computer vision, in Gen AI and all that. But AI is doing it very differently than the way humans are doing. And this is a very important lesson for our students to say, look, there is still scope of doing it differently in a better way. This is the first attempt of mankind to create AI systems, very brute force, lots of label data, lots of compute, billions of parameters. But if you throw that much of resources and claim victory versus if you throw very little resources and still get the same result, that would be true AI, right? So the cost of AI should be lower than the output of AI. That is what we really need to think about. And, that is the next open problem for all of us to think about. Yeah. Now we are also able to generate images, right? So these are not images that we are searching. They don't exist on the internet. So the future search engines, and recently ChatGPT announced a search engine also. So the future search engines will be hybrid. They will say, here are the results from actual stuff on the internet, and here is the generated results for your query, right? On the right side, you see a news anchor. You must have seen this report earlier, right? Now you can create an avatar of a news anchor, and you can say, I want you to wear this sari and this hairstyle and this speaking thing, this background. This is done not in a studio, but on a graphics, GPU, and now you can generate news avatars. Now, why is this creating a lot of trouble? So now imagine Amitabh Bachchan's job is in jeopardy. A.R. Rahman's job is in jeopardy. Picasso's job is in jeopardy. Every creator in the world is now wondering what are they going to do, right? And this is a big problem because it's a good problem and a bad problem. Even after 1,000 years, if somebody wants to make an Amitabh Bachchan movie, it would be possible because GenAI has learned the avatar of Amitabh Bachchan at all ages and how he speaks and talks and whatever dances. And now we can do this forever. A good use cases, right? I want my grandparents to be there forever, so I can create an avatar of them with all their videos, right? I want Feynman to teach me physics. I can create an avatar of that, and he can adjust his language and complexity of teaching to my level and do that, right? So great use cases of GenAI are possible, but great misuses of GenAI are also possible, right? Fake news and all of that. So now we need to tell the great potential, the great harm it can do, and how do we become ethical in using all this, right? Here's another interesting video, and then we'll pause for questions. Yeah.
I am not Morgan Freeman. What you see is not real. Well, at least in contemporary terms, it is not. What if I were to tell you that I am not even a human being? Would you believe me? What is your perception of reality? Is it the ability to capture, process, and make sense of the information our senses receive? If you can see, hear, taste, or smell something, does that make it real? Or is it simply the ability to feel? I would like to welcome you to the era of synthetic reality. Now, what do you see?
Right. And when I watched this video for the first time, there are many thoughts that came to me, right? If you remember that movie Matrix, in that movie, they show that we are all part of a matrix and all that. There's a very beautiful dialogue where this guy says, hey, I'm eating this very juicy chicken, but I know that it is not real, but I cannot let go of it, right? And that is the state of us in this world, right? Our saints have talked about Maya and how all this is not real. Now, physics is starting to talk about why this is all not real. And we are creating now artificial systems like, metaverse and all of that, which is not real. But who is to say that this world is real? Who is to say that your dreams are not real and your reality is real? If we are able to feel the same fear when we dream of a horrible dream, a nightmare, or when we see a horror movie, we feel the same fear, then who is to say what is real? And this is a fundamental thing that is changing now. What is our idea of reality is being questioned in the new Gen AI world, right? So these are not just simple technologies and all of that. These are very profound things. There's a lot of philosophy angle to AI. Obviously, there's a lot of application angle to AI that we need to be able to talk about. Yeah. All right. So I think my time is up. So I'll stop here, but obviously, I could go on for the whole day. There's a lot of exciting things I want to talk about. If there's a future opportunity, I will continue this and we can keep discussing. Yeah. So I'll pause here and take some questions now. Right. Is it 1 hour now already? Yeah. My clock it is showing. All right. So any questions, any thoughts?
Sir, first of all, thank you. Thank you for the session. It's a fantastic session.
Thank you.
Right. I'm a research scholar. My name is Vijay Bhaskar. I'm a research scholar, part-time with Andhra University.
Okay.
I just got the new perception on AI, actually. That's what I would say in one word from my end. Thank you once again, sir.
Thank you. My pleasure.
this is Harshvardhan sir.
Ah.
You've given insights to the AI. That means what is the future of AI? What we need to do in future in the AI evaluation. That is we got a very clarity in this presentations.
Okay, thank you.
Sir, I have a question here. Well,
Please.
I want to know about that actually.
Mhm.
When you talk about AI, we are talking about, as you are telling, right? What could be the ethics and other things and all. Okay. And
Yes.
we are moving from the reality to the virtual reality and all. Okay. And as we know that human being actually learns from experience, and we are experiencing the virtual reality and all. Do you think this is going to create, impact in the next generation that is coming up, who will be having a differentiation on, the reality and virtual reality then, and that could actually affect the, mankind in a, longer run also.
Yes, you are right. So I'll give you a broader answer. See, every time technology takes away something from us, we lose something, right? So what I mean by that is, if you think about when calculators came, right, we lost the skill of calculating in the mind, right? Even for simple multiplication, we need a calculator. Similarly, when Google Maps came, we lost the idea of geography. Today, if you ask somebody to tell directions, they cannot tell direction because they don't even remember the local city that they cross every day, right? Nobody knows where north is anymore, right? Similarly, when ChatGPT has come, now if you don't have to write, you only have to give a prompt, the written text will come. All you have to do is read it, make sure it is correct and all that. And you are only a curator, not a creator anymore as a human being. We are going to lose our literary skills, right? Now, the problem is this, right? So you are right. As technology is progressing, what humans are doing with their brain and mind is reducing, right? And that is a big danger. This is a big debate that should happen in the education system. I was talking to some profs from IITs and all that. They were wondering, should we teach our students programming now in computer science? Because if ChatGPT can do programming also, similarly, English teachers are wondering, should they teach them grammar and literature if ChatGPT can write this, right? We are, art teachers and design teachers are wondering, should they teach their students, all the art and design skills? So this is the real problem. So there are two problems. One is we are going to lose skills. So as educators, we have to keep thinking about, look, calculators came, still we are teaching how to do manual calculation, right? Uh, Autonomous cars will come. Still, we are going to need to know how to do driving of the cars at a basic level. Although cars will drive, but we still need to know, right? So the idea that AI will make us more and more useless, if you will, is true. And we need to figure out what the next generation should learn in terms of skills and how to apply their minds. One argument is now they don't have to worry about driving a car, but using that time they can do something better, right? So this idea that we are going to do higher order things uh, because we are freed up from the chores of simple things is a valid idea. But at the same time, I'm worried that we are losing a lot of skills, right? Next generation will not know how to write, how to calculate, how to drive, how to cook also, because all these are outsourced, right? So that is a danger, and there's no clear answer. And hopefully mankind will figure out what they need to do in the new scheme of things. Yeah.
Thank you, sir.
Yeah.
Sir,
So
as
good
you
morning.
said,
This is
it is getting, more and more people are using and making us useless. But still, even with the current available technology, I still think it is still underutilized.
Yes, it is. Yeah.
In
And
most of the places, we are still underutilizing AI. So, what do you think is stopping, and probably when we'll utilize its best utility, sir?
yeah. So see, there are always what we call early adopters and then late adopters, right? Now, think of any new great technology that came. See, when Ola Cab came, Ola Uber came, not everybody jumped on it on day one, right? Slowly people got used to. When WhatsApp came, not everybody switched to WhatsApp on day one. slowly people switch to it, right? Similarly,
Best
when
example,
search engines came, yes, tell me.
Best example is the demonetization, digital payments.
Exactly.
Now roadside vendors are also having the digital payments.
Correct. So what happens is the creator of these technologies have a very strong belief that this will change the world in a very different way. The users or consumers of the technology slowly come to that realization, right? Today, doctors are doing diagnosis on WhatsApp, right? They are doing patient care on WhatsApp, for example, right? Earlier, we were skeptical, right? So similarly, you are right. ChatGPT is slowly getting adopted, and slowly as people will use it, they'll be wowed by it. They will consume it more and more, and start to depend on it. So today, a lot of people especially in the MBA world, right, the people who have to present a lot, make presentations and all that, they're using it a lot more. But people like me, right, old school, I'm worried that I will lose my own creativity, so I'm not using it for a different reason. But if I have to put together something very quickly, I will use it, right? So yes, right use cases, people will figure out how to use, when to use. Some skill set is required, prompt engineering and all that. So we should teach that to our students and say, let's not stop them from doing their homeworks on it, but let's create a different homework for them, which is more thinking oriented, research oriented, and let them do their research on ChatGPT, come up with the final thing, which is a combination of many prompts organized well. So they learn a higher order skill because this is not going out anytime soon. They have to start using it, right? So we increase the level of how to use it and make it better for their use cases, right? So I think we'll have to adopt, people will have to learn and onboard, and it'll happen because it's a natural transition. All good ideas will eventually get adopted in the world. Yeah.
Thank you, sir.
Thank you.
Sir, this is Dr. Pramod Kumar Poladi from SR University.
Yes.
Sir, thanks for the great and informative session, sir. Sir, one query from my side. Which generative AI application is having more scope for the research, sir?
So I think if you look at, let me give you a very interesting answer, right? So I want you to think about how science has evolved so far. Yeah. So if a great scientist has invented something, it is really serendipitous that he invented something. Why? Because he has happened to read all the right papers, remembered all the content, connected all the dots, and came up with a deep insight, right? Most research is like that, right? Now imagine humans, when they are inventing stuff, they need all this to happen correctly to invent something, right? They should read the right papers and all that and connect the right dots. Now we are limited. We cannot read all the papers, remember everything in the last 100 years, connect all the dots. We have a limitation. But ChatGPT, GenAI does not have that limitation, right? It has billions and trillions of parameters. It's growing, so it can keep consuming new data all the time. So my prediction now is that research will be done not because of serendipity, but because true reasoning capabilities, which are not there in ChatGPT now, but will come slowly with the advent of Graph GPT and all of that. So when reasoning and generation will come together, reasoning is very important, then we will be, not we, AI will be able to invent things at a Nobel Prize winning level invention every hour. Every hour we are going to invent. That is the pace of research going to be. Even today, the pace of research is limited because humans are involved in asking the next question with our limitations, right? Now imagine if AI does not require humans to ask the question also. It sees the whole graph. It sees A to B, B to C, C to D connection. It sees that connection P to Q is missing. If that connection was there and it is not present in all the literature of the world, if P to Q are connected in such a way, then I have found a cure for cancer. Now today, to find cure for cancer, millions of researchers are looking at millions of records and data and studies and genomic patterns and all that. It is not humanly possible to go through that complexity. But AI can go through that complexity. So my submission is a research co-pilot, not a software co-pilot or a journalist co-pilot or a painter co-pilot, a research co-pilot, which is all knowledgeable, has an extreme research thinking and reasoning capability and all knowledge of the world, will be able to do research very quickly compared to all the humans that have ever done research so far on the planet. This is the power that we are dealing with, and we should encourage our students to build systems like this, right? Reasoning systems, consuming all knowledge in all domains and do reasoning now and see what comes up. And now the AI will tell a drug discovery guy that you need to do this experiment so that P and Q relationship can be validated. It's not there in any literature. So AI needs to tell humans what experiments to do so that it can complete its knowledge graph, so it can continue to do reasoning. This is the future prediction I have, and you'll start to see that articles are written by AI, Nobel Prizes are getting won by AI in the near future. So it's a very beautiful, dangerous, but beautiful future. We don't know what we will do, but we will create a system like that, right? So we need more Sam Altmans in the world who will create the next generation version of AI. Yeah.
Thank you, sir. Thank you very much.
Thank you.
Participants, anybody is having any queries?
Sir, one last
thing
is that, sir, it was very interesting, sir, actually, because the way you have, explain entire, concept and taking out, it's very interesting. Actually, this is something we should tell the student also to how to understand and the AI itself, creativity, and how to actually apply itself. I just want to have a, from your understanding perspective, like you are talking about the avatars and all, right? We can regenerate our old young age also, right? We can get the things back into this. Do you think that the possibility of AI and time machine can be one of the reality in a coming days in life?
Time
Like
machine, time travel,
time travel machine, right? Most probably like a virtual reality, we can travel somewhere and we can go back to our old young stage, something like that, recreate our what do you say, past experience, memory, something like. Do you think something like that can be a real fascinating in the coming days, right, sir?
Yeah. I'll show you the glimpses of it has already started. If you look at your Google Photos, right? Now, what does Google Photos do? It basically says, 9 years ago, 10 years ago, this is how it was, right? Because we have photos. We have told Google that this is how I looked like 9 years ago. And Google is now able to do that. This is the early stages of what you're trying to say. Now, imagine I have recorded everything, taken all the photos, all the videos, and I have put it there, right? The memory has to be there somewhere. So either it's my human memory or it is my digital memory. And if that memory is present somewhere outside in Google Photos or inside my brain, I should be able to go back to those memories and do a time travel, right? So with the new advances in Neuralink, for example, right? The Neuralink from Elon Musk, now that can trigger certain memories in the brain. Old memories are also there all the time. Psychiatrists and regression therapists can evoke those memories. So it is possible, theoretically it is possible. It's just that somebody has to create those systems where you can go back in time, relive certain moments if you want. Could be a new next generation startup idea, right? And a lot of people want to do that, and why not? Future travel, I don't know. That is a physics question, not an AI question. Is it possible or not for time travel in the future? We don't know. Yes, people are clairvoyant. If you look at Nostradamus and prophecies that people do, some people are able to do it, but that skill has nothing to do with AI. That's a human skill. Clairvoyance is a human skill. Telepathy is a human skill. And, sometimes I talk about how if humans had developed clairvoyance and telepathy and telekinesis, then we would not need technological way of doing the same thing. We would be able to do it ourselves, right? This is another perspective to think about. Okay, we have invested trillions of dollars on outsourcing our capabilities into machines. But if we had spent even 1% of the money to develop telepathy in humans, right? Then we won't need a telecom network, for example, right? We would be able to communicate directly. Today, we are communicating in so many other ways, right? We won't need a search engine if we had developed the clairvoyance ability. And there are words for it in Sanskrit and many languages. That means those skills were present in our rishis and others earlier. So I think what will happen to the future of humanity? Technologically, we'll make a lot of progress. We'll get sick and tired of it. And then we'll go back to spirituality and other such skills. So this is going to happen. It's just a matter of time. While we are in this way, we need to continue. When we will go to that way, we will figure that out. Yeah.
Right, sir. Thank you,
This
sir.
cycle will go on. Yeah.
As
But
Gita said,
please,
sir, yes, sir. Right. As a life is a cycle itself, so it will go back
correct.
again. Right. Yeah.
Correct.
Thank you so much.
So,
Really, yeah.
I would love to come to your colleges virtually or physically, give like a half-day session. I have a lot of things to talk about. This is just one section. I have 5 more sections, different perspectives, right?
Right,
So, I would love to come to your colleges if it is nearby, or do this online with your senior students, MTech students to third year, fourth year students. So please use me as much as possible. I would love it. Yeah.
Sure,
Sure,
sir.
sir.
Thank you so much.
Thank you.
Thank you. Thank you.
Thank you.
Sir, Dr. Satish Shailesh garu.
Yes.
I'm Dr. Srinivaslu from Institute of Aeronautical, Professor of CSE.
Yes.
So really, you are given very good insights about. I'm recently exploring this new area. Yeah.
Yes.
So we'd like to invite you to our college for any guest lecture. Do you have
Sure.
any contact them or shared with these people or?
Yeah, let me put my WhatsApp number here, 91807. So you can please WhatsApp me on this. I will, if it is, so I travel to Bangalore, Mumbai. I live in Hyderabad,
Where is your
Delhi.
institute, sir?
So I can come if my time permits. I can come or I can do online. But I would love to come. But when I come, I don't need 30 people in the room. I need 3,000 people in the room because the highest ROI you can get from me is when lots of people are there. They're all able to benefit from this live session, right?
You are currently located in Mumbai, sir?
I am located in Hyderabad and I travel to Mumbai a lot. So Mumbai, Hyderabad, and but I can come anywhere, no problem, right? I travel to Odisha, I travel to all these places to give talks and all that, so no problem.
Okay,
Yeah.
then Hyderabad, no problem. Our institute is also in Hyderabad.
Oh yeah, please. I would love to come, no problem. Yeah.
Thank you.
Okay. Thank you.
Thank
Sir,
you,
one
sir.
last
Thank you.
question.
Thank you. Yes, please.
Sir, can I take one last question?
Yes, sir.
Yes.
This is
So,
the last
sir,
question, please.
maybe out of the context, but I mean, with this development in AI and all, what will be the future of hardware improvement? For example, Intel is actually investing their amount in neuromorphic computing.
Correct.
And people are talking about quantum computing.
Yes.
So when total computing changes, definitely the physical structure, or I would say the hardware systems will change.
Yes.
Can we have light on that, if it is if possible?
Yeah, you're right. So I think, see, when CPUs were there, we were still doing computer vision, right? But when GPUs came, suddenly our ability to do computer vision accelerated, right? Because we can do matrix multiplication. Now, when quantum computers will come, the same algorithms can now be done in a quantum matrix multiplication way, for example, right? So what we call NP hard problems today may become polynomial problems in the quantum world, right? Right. So the idea is that as compute technologies evolve, new paradigms will come. They will continue to evolve. So the hardware will continue to evolve. The brain will evolve, and the mind will also evolve. The algorithms will also evolve, right? So XGBoost was not there, now it is there, right? Transformers were not there, now it is there. So the theoretical and mathematical formulations will also evolve, and hardware will also evolve. And the hardware evolution will make sure that the layers of abstraction are so easy for you to use any hardware on any software. See, that is the job of a computer scientist, to make sure that, I can run my same traveling salesman problem optimization on a quantum computer as much as I can run it on a CPU. And the reason is that these two things are abstracted out. So you're right, the Moore's law has been broken. Quantum is coming, neuromorphic, biological is coming, many forms of computing will evolve. So we need to encourage our students to think about that as one dimension. And algorithmic improvements will also happen all the time. And the bridges will be always there, right? And as it's like hill climbing, right? You fix one step, you go to the next. So with the current state of hardware, what is the maximum we can do on algorithm side? And when the new hardware will come, then what else can we do, right, beyond this? So I think 5 years ago, we could not have imagined, even this conversation, we could not have imagined, right? Across the world, people doing WhatsApp video calls, we could not have imagined. So even today, we cannot imagine what will happen in the next 5 years. This is the ambiguity that we are dealing with. And it's amazing and mind-boggling, right? In a good way and a bad way. So yes, you're right. We'll continue to evolve, right?
Yeah.
And I'm very excited that we don't know where we are going with all this.
Right, sir. Thank you once again, sir. Thank you very much.
My
It's
pleasure.
been
Yeah,
great.
Thank you. Thank you, sir. Yeah. All right. See you soon.
Thank you, sir.
Hopefully, I'll meet all of you sometime. Yeah. Thank you.
Thank you, sir. Thank you very much, Shailesh Garu. Really, you have taken us into a new world. Actually, we thought about coding and LLM models, but we learned that what is an AI, where we are, what next we need to do. Completely, you've taken us into a new era and new world, sir. We learned a lot from this presentation, sir, and we really appreciable at this age you are ready and you are showing the willingness and enthusiasm to interact with the 3,000 of students. That is a really appreciable, sir. Definitely we'll utilize your resource, sir.
Yes,
thank you very much, sir.
Thank you
for your patience and time.
Yeah, my pleasure. Thank you.
Thank you, sir. Thank you so much, sir.
Thank you.
Anuradha, madam.
Yes, thank you, sir. Thank you so much, Shailesh, sir. This is Anuradha from Blackbox,
Hi,
and we've been associated with you for some time. Thank you so much for this session. I see that most of the honorable faculty have really enjoyed this session. Thank you once again, sir. We'll get in touch with you soon.
Yes.
Thank you, sir. Thank you.
So dear,
participants,
just give me a second, sir. So, dear faculty, the next session will be from Mr. Mauli, who is current CTO of RSPL Group, and you can expect the same level of discussion happening in the next half an hour and in the afternoon section. And it's really he's going to be both the conceptual wise as much as similar to Dr. Shailesh, and also he is also a hands-on person. He himself is an entrepreneur in generative AI. So please hang on to this. Dr. Harshavardhan, do you want to speak, or I need 2 minutes?
Yes.
On
I invite our colleague Sharanya madam to introduce BC Mauli garu.
Okay.
Yeah, good morning, everyone. I would like to introduce Mr. BC Mauli, sir. BC Mauli is a seasoned technology leader with expertise in building large language models, chatbots, and AML solutions. Currently serving as a Chief Technology Officer at RSPL Limited, he focuses on developing and managing e-commerce platforms, enhancing user experiences through NLP and machine learning. Previously, he held the position of Head of Technology at Mac AI, where he worked on AI automation and deep learning applications. Mr. Mauli has a strong background in digital transformation, predictive modeling, and natural language processing with a passion for leveraging machine intelligence to improve human endeavors. His experience includes roles at Scient and KPMG, where he contributed to various technology initiatives. He holds a Bachelor of Engineering in Industrial Engineering from Dr. Ambedkar Institute of Technology and possesses certifications in coaching and assessments. His skills encompass machine learning algorithms, e-commerce, and advanced AI technologies like GPT and BERT. Thank you, sir, for joining us today. A warm welcome, sir, from me and everyone. You may please take over the session, sir.
Thank you. Good morning, everyone, and wonderful. Thanks so much for kind words. There is no way that I could imagine to emulate what Dr. Sailesh has accomplished and his perspective way beyond how we imagine things. Yet, I think we have half an hour. Probably what we could do, we could use this for conversation. What if you have anything that you want to share, want to try, want to know, probably that would trigger for me to get the dialogue. Otherwise, if you want me to go monologue on specific areas, I'm happy to do that.
No issue, sir. If you want to extend, anyway, we are having the afternoon session from 2 to 4. If you want to extend till 12:30 also, will participants will stay.
Yeah, there is what we could do, Doctor. The post-lunch session is about chatbots and how do we build chatbots with pre-trained model. So what we can utilize that time where we will try to build, I'll showcase one pipeline and the chatbot that is being built. And then we will look at generative AI. Do you use any generative AI other than GPT APIs today? Any of you?
In the last classes,
generally, see,
summarization tool. Day before yesterday, we have used
summarization. Okay, in
PDF question and answering, YouTube summarization.
Okay, so post
I use Google Gemini a lot actually. Google Gemini I use a lot more.
Google Gemini, is it? Okay. So what we will do, I will try to build a small model post-lunch. We will use GPT, we could use GPT APIs and see. And then I can also take you through one chatbot pipeline that is currently being available for 850 clients. 2.5 million users have access to it. 25 lakh people have access to it. So we can spend time on the chatbot, on development post-lunch. So now this time we could use in the last few days, based on your learning, what are the thoughts that you have and what queries would you have?
Participants, you may interact with him. So we're going to have a hands-on session in the afternoon session regarding the GPT models.
Yeah, good morning, sir. My name is Vijay Bhaskar. I'm a research scholar with Andhra University. So what my, being a research scholar, I have a confusion that, where have to start the research in the AI field? That's my,
Okay. So let's try to condense this AI into a smaller aspect. The artificial intelligence is an umbrella term. It's like mathematics as an umbrella term, and there's so much below that. So within the artificial intelligence, I'm guessing you're all more keen about machines learning by themselves. It's like humans, right? So we, over a period of 10, 15, 20, 30 years, we keep observing and learn, and then we respond. So we are generative. We don't need to hear and memorize this exact phrase in our brain. We can generate, and we don't have to see a particular image before we can even predict what it could be. So machine learning is a subset of AI where machines also learn by themselves the way humans do. To this extent, I'm okay. Is that your focus area? Excellent.
Yes.
Now, you can further segregate machine learning into 3 categories, and then we will talk about a 4th category. First, you can use the algorithms, a set of instructions to predict something, to predict or to estimate something. It could be what can be my next month's sales. It could be whether it will rain tomorrow or not. Yeah, and so on and so forth. So these predictive models are very, very easy for machines, computer machines to build, because a lot of computer machines, you all know, it is electric pulse, right? The light, the voltage is there or not, 0 and 1. So anything that is in numerical format, machines will understand. Now, when we are predicting, let's say, sales of next month, we look at various parameters. Some of the parameters are quantitative in nature. That is, last 5 months, what are the sales? And next is what is the price? What is the price of the products? Next could be how many employees do we have? Salesmen do we have? Then we can also have, next is region. So in similar regions like Telangana, like Andhra Pradesh, what were the sales in other regions? Now, region is not numerical. How do you deal with the non-numerical regions of a country, let's say states? How do you deal with it?
Yes.
These are categorical data, right? You
Yeah, yes.
categorical data. You use one hot encoding. So you try to convert based on the number of the variety of the regions. You use the vector size of that length, and then say, let's say there are 10 regions. You say, okay, my vector length is 10, 1, 0, 0, 0, 9 zeros will be the first region. Second region will be 0, 1, remaining 8 zeros. So this way you convert this into multiple variables and deal with it. So in the predictive models, anything that is non-numerical, you try to convert that using one hot encoding or any other method, but you convert everything into numerical formats. Super easy. So this is one. Second thing is image processing. So numerical processing is, image processing, if you want to recognize who the person is, you want to describe an image. So for the image processing, we've gone to a next level method. We said we will break down the image into pixel level. And you may have heard of these convolution methods and YOLO, you only look once, where it looks at every pixel based on the surrounding pixels. So at the end, what we are doing, every pixel has a density of 0 to 255, and every pixel, it's like our characters are defined by the people who surround us. Our friends define our character, let's say. So people around us are, let's say, friends. In the same way, every pixel's density is also determined by the pixels around it. Blah, blah. Now, basically, the whole a large image an image with a large number of pixels. Let's say today's computers, we have 1,000 by 1,000. It's 1 million pixels. The input variables are 1 million variables. Now you downsample it, we call it as convolution method. You downsample to a smaller one so that the noise is removed and high density image you get. And finally you process it and say who that person is. Whether there is a presence of a person or not. Two Tesla car Dr. Sailesh was referring to. Somebody in my extended family has Tesla car, so whenever I go to US, I use that car. So that car I don't have to drive. Every 20 to 25 seconds once, I have to keep my arm on the steering wheel and everything is taken care. Now what is it doing? It has cameras fitted all around. It is capturing the images and the motions of those images, videos, processing to see whether they can become an obstruction to the car, and all of it in a split of a second, and then determine whether it should accelerate, maintain the same speed, or apply brake. All of it does by itself. Or should it steer the direction, change the direction to another lane, or so on. So now see the kind of variance in the applications. One, we are saying whether there is a cat or not in the image, whether there is a person or not in an image. Two, capturing live in a millisecond, in just about 4 or 5 milliseconds. It is capturing the whole environment, its motion and everything, and determining the speed of the car. It's the other end of the spectrum for image processing. So this is second type. The third type is text processing. So some efforts have, I think Dr. Shailesh also referred to text processing a bit, where he spoke about transformers. Would you all be familiar with transformer architecture?
Yeah, we've been too exposed to these days.
Fantastic. Okay. Yeah. So transformer architecture, you have seen there are two blocks at a high level, right? So the left block is called encoder block, right block is called decoder block. Anything that you do in the encoder block is about understanding the language. So it's about NLU, natural language understanding. Google is extremely good at it. So their algorithms historically been about when a user writes a text, uh, how exactly it understands what user needs, so that it can go to its database and fetch the right response. So the encoder side of it is a lot focused on the natural language understanding. On the right hand side is the decoder. Decoder is about generating the text. So one side is understanding the text. So the other side you call it as NLG, right? Natural language generation. So decoder block is built in such a way that it can spit out, it can generate text. Typically, I think Google, when it started Word2Vec and subsequently BERT, they have identified either 27,000 unique words or 31,000 unique words. Now, let's say these are 27,000. That was the first iteration, 27,000 words. So this original transformer architecture was generating one word at a time. So when it generates one word, it has to give a probability to all 27,000 words, and whichever has highest probability, it was spitting out that word. So that's and a word after word, word after word. And when it will have a threshold, if it says, okay, now after this, the last one, let's say, is full stop. After the full stop, the highest probability one is 0.3, which is while my cutoff to generate next word, to throw next word, is 0.35. So therefore, I'm stopping my response here. So blah, blah here. Now, text processing is the third. So if you look at machine learning, your research can hinge upon, should I get into a simple numerical data analysis and predict whatever is the use case need, or should I process the images and predict something related to images, or should I work on the text and uh, predict something or build something, do something with the text. One of these three you could choose, and there is fourth one. It somehow became part of the machine learning. It's reinforcement learning. Reinforcement learning works by the principle of reward and penalty. So whenever it makes the right step, you reward that step saying this is a right step. Whenever it makes a wrong step, you give feedback by saying this is a wrong step. So you penalize it saying wrong step. So penalize, you would know it is all about weight matrix, right? If you have 5 variables that determine height of a person or age of a person, now which variable has higher impact? It is a function of which variable has got more weight. So that weight distribution is a determinant. Now in reinforcement learning, when I say reward, you give higher weightage to it. Penalty, you reduce the weight or you keep a negative weight to it, so that the following time it will not move. Now, when you now make a choice, which one you want to do? Easiest is get to the numerical data analysis. Complex is text analysis.
Okay. Thank you so much, sir.
Sir, may I know regarding federative AI, sir? What could be the subject it contain? Just I have heard this word, federative AI.
I will talk about it post lunch.
Okay.
I'll talk.
In
Go ahead.
continuation to that, sir, I'm Vijay Bhaskar again. So yesterday we got some inputs, like, so ChatGPT, when we are giving numbers, it's not working properly. It leads to hallucination or something like that.
Okay.
So like, even that could be a research area, like, if you can train mathematics to the GPT, can it be a research area?
Repeat again. What exactly would be the question here?
So GPT,
I will give you as the chart GPTs are trained based on the text basis.
Yes.
So it can understand the text and it can analyze the text only after converting the text into the numbers. But we are not given the training to the chart GPT on numerical system basis. So if you give some mathematical operations to the chart GPT, in some cases it will give the wrong result. The reason is that the ChatGPT models are not trained on the numerical system basis. So if I take that concept, it could be the one research topic is asked.
Yeah. So who asked this question? Federative AI?
Myself, sir, Harshavardhan.
Dr. Harsha, you asked. You are an electronics engineer or a computer science engineer?
Computer science.
Okay. So then you mean federative learning, right? Federative AI means.
Yes, yes.
We will discuss that. So so it basically it can assure you better security and privacy. So how exactly we can operationalize? We'll discuss post lunch. All right. So you are now asking.
Are there any?
Go ahead.
Are there any LLM models for this mathematics, or what is asking?
Yes, I will finally conclude with it. I'll start with why is that the large language models are not accurately responding to mathematical computations, right? Now,
yes, sir. Yes, sir.
Yeah. So now we all agree the language model is a probability distribution. It's a probability distribution. So when I want to say that, let's say that we all coming together is very exciting. It's very exciting that so many professors are together discussing a particular topic. This is one way to say. I can also say it's so nice to see that so many professors have interest in this. I can also say looks like there is a lot of emphasis in academics to talk about machine learning. Now, are all these three statements correct? Broadly right.
Yeah.
Broadly right. Now, in the communication, you have variance. You can express it differently and still convey somewhat similar meaning. In mathematics, there is nothing like that. You can express differently if you use symbols, but then when it comes to numbers, they're absolute. It is a single number. Now, so when we compute what is 7 into 8, I will add 7 8 times and then I'll give a number. If I have to predict what is 7 into 8 from my mind, I will not say every time 56. I can sometimes say 54, sometimes I will say 63, sometimes I would say 56. When I have to predict, try to make a guess, like the way in English. Numbers work in absoluteness. They will not do well if it is about guessing. Now, we all need to accept that it's in the probability distribution. Sometimes it can miss out. While so many iterations captures essence of multiplication, addition, and division so well, still for complex mathematical query, a standard probabilistic model will not give 100% right answer. You agree with me or any questions on this?
Yes,
Then I'll
sir,
go.
I agree with you.
You agree, right?
True.
Now, how are these guys managing? Look at GPT, OpenAI. How are they managing? Are they having a single block of language model where we ask a question, it is answering? No, it is not like that. There are validators. So the validate. Go ahead.
Agents. Can we call it as agents?
You can call agents. Yes, you can call. Let's say broadly the question that comes, is it a text query or an image? Nowadays GPT you also have image, video and all, right? So let's say first step is it segregates the question. Is the question is text, numericals, image, let's say these three. Now if the question query that you pass has all three, so it breaks into three pieces and send it to them. Now numbers one has gone to number, so the number then will have a set of rules, huge set of rules. It will pick up symbols whenever it says multiply, cross mark, star. It will pick up these as these symbols as multiplication. So this is a set of rules that is set up, and then the remaining text is passed to the language model. So there is that one language model or segregated language model. It will give the response. The what language model is giving is now a proper mathematical equation. It then takes that equation, the rules that we have, simple computer that we have, it gives an answer. 7 into 8 is 56. And then if there is a text or image, it comes out, it adds the response with the other two responses, and then there will be another filter that says homogenizes all these responses, and then there will be another filter. It says for every question you have to start with answering this, your question is this, I appreciate that you are thinking like this, and then provide answer, and at the end summarize whatever you have written from top to bottom. Now how many layers are here now in this example? Layer 1, our question has gone to one of the three, text, number and image. Layer 2, in the number we looked at a set of rules. Yeah, even before rules you need a language model that breaks it and makes meaning out of it. So layer 2 is making meaning. Layer 3 is full-fledged language model that makes whole thing into a simple equation. Layer 4 is rules, basic computer, that is fetching the response. You have 4 layers like this, and when you come back you have a 5th layer of summarization, and then validation and summarization, 6th layer of appropriately presenting to the user. Did I make sense? There are 6 different layers here.
Yes, sir. Yeah.
Now, every language model do not make this much investment. We will try to be very, we will try to say, generally don't build any language model from the scratch unless it is extremely narrow requirement. The requirement is so small that you don't want to pre-train. You don't want to take a pre-trained model. Otherwise, when you take a pre-trained model, you try to get meaning out of it. You may not have these many layers. So you could then do your research on how, let's say, how a stream of models can handle computations accurately. Then there you use your metric as accuracy and analyze how accurately it is able to respond simple mathematical computations and complex mathematical computations. Decent research area.
Thank you so much, sir.
Next question was, which language models are there for computation purposes? I do not know, but I can come back with an answer. Last time I was working on Llama, Facebook, they had a specialized model for computations, but post lunch I will look for current powerful models with good, with high accuracy and precision and so on, and suggest.
Okay, sir. Sir, this towards this digitalization, the India.
Go ahead.
Sir, is it developing any LLM models towards this digitalization of India?
Yeah.
So, government of India, what are the LLMs it is developing?
You're asking, okay.
Just I have a few detectors.
I am unaware. First, I'm also super skeptical about how guarded India has become, because I think the electronics, whichever is the department which handles, which has said anybody who is building LLM in India has to get it approved by the Department of Electronics, and there is this team. So that is one. That is a huge constraint on startups on your models. So long as you are building it for academic purpose, it doesn't make any huge ruckus. But if I build a language model by myself, and commercialize that language model or promote that language model, then the government of India has restrictions. Now, are they building? I'm not aware of it. One. Two, you would have heard of this DPDP Act. So again, the same department has come up last August, and this year, June or July, it is expected to be mandated, or by August, where they said digital data protection. So digital protection of data privacy or something like that. Digital Personal Data Privacy Act. So these are more restrictions. I don't see they are contributing to generation, but I will check and revert on this also. You had so many topics being covered. Any other question you have on the subject? Okay, let me ask, what is the difference? What difference have you recognized when the text processing happens using machine learning and using uh, network methods, deep learning methods? What is the major difference you saw?
Yeah, more accuracy you will get it, sir.
Yes. Now, in your in the way of development, go ahead.
Deep
Sorry.
in networks. Yeah, okay,
Deeper.
sir. Yeah, deeper. That's why it's trained well, and also we'll get accurate. What are the prediction or what are the thing we are expecting?
Yeah, yeah. So what you would have noticed in bag of words is that you're only playing with the strings, right? You're playing with the strings. A word is there. You could have, you break a paragraph into a set of words, and each word you do the term frequency. And or you could have done n-grams, where you combine word 1 and 2, word 2 and 3, 3 and 4, like that. 2 gram, then 3 gram or 4 gram. So in all of it, the limitation is your input is only determined by your number of strings, or into 2 or 3 times of the strings. This was in machine learning. Now, when it comes to network methods, there are two things that happen here. Even before you go to network methods, the first discovery is it is vector representation of a word. We started representing a word in the form of a vector. And now the vector length, the longer the vector length, the more information about the word and the adjacent words of a word and adjacent sentences of a word could be captured. So now, what was the longest vector size of a word that you learned during the classes? Okay, I see here BERT, bidirectional embedded representative transformers were taught on Tuesday. So BERT, it's bidirectional. Every word meaning is pulled based on forward sequence and backward sequence. One. Second, I think in BERT, a word is represented in 512 dimensional vector. Huge dimensions. One word is represented in 512 dimensions. Now, these are they capture the context of words so much. It's a deep contextual word representation. That vector, 512 dimensional vector, is so deep contextual word representation. So I'll give this example of broke. Let's say vase broke, flower vase broke, and dawn broke. Dawn broke. Dr. Chandrasekhar broke the record. Now, in these three cases, the word broke is same exactly. But then in the first case, broke would mean the flower vase was broken. And in the second case, it had dawn broke and it became a day. We have sunlight. In the third case, Dr. Chandrasekhar broke the record, which means he led. He is leading in that area. Now you see so much difference for exactly same word. And I think there are many other illustrations for the same word. This differentiation in the meaning is so well captured when your word vector length is wide. So this is the first great achievement we got, and this was in 2011 and 12. Word2Vec. This Word2Vec was by Google, then Global Vector by Stanford, and some contribution from a third party. But otherwise, it was a Stanford work. Since then, nothing stops. So, today's vector lengths are so wide and so deep, they rarely miss a meaning. The next aspect that happened in deep learning, you have the network methods. And you started saying it is a deeper network. Here, deeper network would mean your dependency of weights is not just a function of your input variables. You can create artificial variables in between and create many more weights. I'll give another example here. Let's say you are predicting age of a person by looking at height, gender, weight. Okay. Now, normal linear regression suggests to predict the age, you add a weight matrix to each of these input variables. You can add 3 weights, 1 weight each to height, weight, and gender. And then you could have some sort of a bias added. So totally you can have 4 weights. So now these weights are always dependent on, in machine learning, number of input variables. In a network model, because you're anchoring artificial layers in between, the more layers you create, the more number of artificial variables that you create, those many additional weights can get generated. So this is the next powerful. So traditional machine learning was not at all good with processing the text. Not at all great with the processing text. At Google led beating Alta Vista, beating AOL and others in 1990s, late 1990s, and turned out to be a leader in the search because their search algorithms were far superior to others. So they were able to do a better search. Slowly they moved to machine learning, where they continued to be the leader. From machine learning, they moved to they're moving to, or now moved to vector representation of a word. Then they became a lot more accurate. And now anybody who is looking at the text processing, they rely a lot on the network-based models. Is my explanation clear, or what do you view?
Yeah, it's clear, sir.
So post-lunch, 2 to 4, we will talk about some bit of prelude to chatbots. I will take a GPT API and see if we can run something quickly live. I will definitely share with you the pipeline that I built in the previous organization. So, and that is live now for all their clients. It is working. I'll talk about that. Some of the questions that I have, I'll explain. Federative AI, we'll see if I can pull a diagram, any powerful model who is using diverse set of infrastructure and run and have trained any model. I'll use that example to explain that. Any other questions? If you have, share here. Probably it will also give me time to refer and come back. Mathematical equations and Government of India's efforts, I will report. All right.
Okay, sir. We'll wind up this session at this point. We'll come back at 2 p.m. Sure. We'll start. Participants, the same speaker, Molly sir, will give a presentation and hands-on session in the afternoon session from 2 to 4. That is the last session. I hope definitely this could be the memorable session for you all, like Silas sir. Thank you, sir. Thank you very much.